Good morning, everyone, or evening, whatever time you happen to be watching this. This is just a quick little review for the 1.6 page of your summer review math packet. So it is on solving linear inequalities, and let's just first start with what is a linear inequality. Can look like any one of these. So ax plus b is less than 0 or less than or equal to 0. Ax plus b greater than 0 or greater than or equal to 0. What about a solution? How do we solve these? Well, a solution of an inequality in one variable is a value that when substituted for the variable gives a true statement. So for example, is 3 a solution to this first one over here? X plus 2 is less than 5. Well, we plug it in to find out. If I plug in 3, 3 plus 2 is less than 5. Well, I would get 5 is less than 5 then. That's false. So no, 3 is not a solution. How about x plus 2 is less than or equal to 5? Now if I plug in 3, 3 is a solution because I get 5 is less than or equal to 5, and that's true. All right, so what about the graph? Let's review what the graphs of these inequalities look like. It consists of all the points on the number line that represent solutions. So x plus 2 less than 5, we subtract 2 from both sides, we get x less than 3. And the way that we draw this is, since we don't want to include the 3, we can't have a closed circle there, so we put an open circle, and we want to shade to the left. All right, so like this. And then if we were going to graph the other one, x plus 2 less than or equal to 5, again, subtract 2 from both sides. We get x is less than or equal to 3. This time we would want a solid dot at the 3 and shading to the left. All right, how about this example? This is a compound inequality. If negative 2 is less than x and x is less than or equal to 4, by the way, that's how you read this. Negative 2 is less than x and, it's got a hidden word and there, and x is less than or equal to 4. That's basically all of the points between negative 2 and 4, but we don't want to include the negative 2, and we do want to include the positive 4. So that's going to be a graph that looks like this. All right, how about this example? This is another compound inequality, but instead of and, it has the word or. So now we want x less than or equal to negative 1. That would be solid dot at negative 1 and shading to the left. Or we want x greater than 3. Open circle at 3, shading to the right. And that's how we would graph that. All right, let's take a look at solving. You need to get x by itself in this case to solve and then to graph. So let's divide both sides by a negative 3. And we would end up getting x is, let's see, over here we'd have a negative 5. But since we were dividing by a negative number, if you multiply or divide by a negative number, you need to switch the direction of the inequality. So that means we need to switch that from greater than to less than. And so now to graph this, we need an open circle at negative 5 and shading to the left. All right, so don't forget, if you're multiplying or dividing by a negative number, you switch the direction of the inequality. Okay, so let's practice, not that one. Interesting. Let's see. Okay, so let's try this example here. We're doing 2 is less than 3x minus 1 and 3x minus 1 is less than or equal to 6. This is a compound inequality. We need to solve for x. So whatever we do to this middle part to get x by itself, we have to do to all three parts. First step here would be to add 1 to all three parts. So we would get 3 is less than 3x. And 3x is less than or equal to 7. And the next step to get x by itself would be to divide everything by 3, so we can get x by itself, but that means we've got to divide all three parts by 3. So we would end up getting 1 is less than x, and x is less than or equal to 7/3. That is 2 1/3. So I'm going to put a closed circle at 2 1/3. And since that's not actually on my number line, I don't see 2 1/3 written, I need to write it in. So there's 2 1/3, and then here's 1. Right here, I want an open circle there, and I want shading in between. So that is my graph. All right, let's look at one last example, and this one is negative x minus 4 is less than or equal, I'm sorry, greater than or equal to 1, or 2 minus 5x less than or equal to 8. Again, we're solving both of these separately now, so we're going to add 4 to both sides. We'll get negative x is greater than or equal to 5. Let's divide both sides by a negative 1. But that means we're going to be switching the direction of the inequality because we're dividing by a negative. So we get x is less than or equal to negative 5. Or something on this side, with this part, we are going to, let's say, subtract 2 from both sides as our first step. So I get negative 5x is less than or equal to 6. And then we will divide both sides by a negative 5. Again, since we're multiplying or dividing by a negative, we need to switch the direction of the inequality. So we're going to have x is greater than or equal to a negative 6/5. All right, so at this point, if we were going to graph this on a number line, let's see here, 0, negative 1, negative 2, negative 3, negative 4, negative 5. We would have a closed circle at negative 5 and shading to the left, and an open circle, no, I'm sorry, closed circle also at negative 1 1/5 because that's negative 6/5. And shading to the right. Okay. All right. That's it for this little refresher video, and I hope that was helpful. And feel free to check out another one of our little refresher videos. Have a good day.